Lesson 11-3, multiplying matrices. Two matrices, A with dimensions of M by R and B with dimensions R by T, can be multiplied if and only if the number of columns A is equal to the number of rows in B. So the product of A and B is the matrix of M by T matrix called matrix AB. When you put the dimensions side by side, the middle two have to be the same number. So an example, if I have multiplying A by B, I have a 2 by 2 and a 2 by 2. The middle two are 2's. So if I have a 2 by 2 and a 2 by 2, the middle two are the same. So my answer is going to be a 2 by 2. And so when we multiply, you're going to take this row 1 and you're going to flip it and multiply it by column 1. And then you add your answers together. So it'd be A times B, or A times E plus B times G. And to find this part, this is row 1, column 2. So I'm going to take A times B, A and B, multiply it by F and H. So A times F plus B times H. Add them together and gives you this. This part here is in row 2, column 1. So I'm going to rotate this, so it'd be C times E plus D times G. So let's take a look at an example here. Determine whether each matrix product is defined. If so, state the dimensions of the product. So here I have a 2 by 3 times 3 by 4. The middle term is the same, or the middle numbers are the same, so yes. And the dimensions would be a 2 by 4. This one is a 3 by 2. This one's a 3 by 2. The middles are not the same, so no, this is not, I cannot multiply, it's undefined. Next, these middle two are different, so no. This one is a 3 by 2. This one's a 2 by 3. The middle numbers are the same, so my answer is going to be a 3 by 3. Next, determine whether these can be defined. So 5 by 4, no. Here, this is a 1 by 2. This is a 2 by 1. Middle term is, so the middle two terms are the same. So yes, this is a 1 by 1. Now we're going to do the multiplication. So this is a 2 by 2, and this is a 2 by 2. So my answer is going to be a 2 by 2. So I'm going to have this one, I have this one, I have this one, and I have this one. So to find this position, this is row 1, column 1. So I have 1 times 5. So I'm going to do 1 times 5 plus 3 times 9. So 5 plus 27. 5 plus 27 is 32. Next, this is row 1, column 2. So now I have 1 times negative 2 plus 3 times 4. So negative 2 plus 12 is 10. This is row 2, column 1. So I have 8 times 5 plus negative 4 times 9. So 40 plus 30 plus a negative 36 will give us 4. And here, row 2, column 2. So I have 8 times a negative 2 plus a negative 4 times 4. Negative 16 plus a negative 16 is a negative 32. So this would be my answer. So again, you'll notice here just the steps if you need to see the steps again. Row 1, column 1, so 1 times 5 plus 3 times 9, and so forth. Second example, find A times B. So again, this is a 2 by 2. This is a 2 by 2, so my answer is a 2 by 2. So I'll do the same thing here. So row 1, column 1. 2 times 3 plus 5 times 7, negative 6 plus 35. Negative 6 plus 35 is 29. Next is row 1, column 2. So we have negative 2 times negative 1 plus 5 times negative 3. So we have 2 plus a negative 15 gives us a negative 13. Next, this is row 2, column 1. So 8 times 3 plus negative 4 times 7. So 24 plus a negative 28 gives us a negative 4. And our last one here is row 2, column 2. So we have 8 times negative 1 plus negative 4 times negative 3. So we have negative 8 plus 12 gives us a positive 4. Another one, here's a 2 by 2 and a 2 by 2. So my answer is a 2 by 2. So we have these. So row 1, column 1. So 0 times 2 plus negative 6 times negative 3. That's 0 plus 18, so 18. Then we have row 1, column 2, so 0 times 1 plus negative 6 times negative 6. This will give us 36. Next, row 2, column 1, so 4 times 2 plus 5 times negative 3. It gives us 8 plus a negative 15 gives us a negative 7. And the last one is row 2, column 2, 4 times 1 plus 5 times negative 6. That's 4 plus a negative 30 gives us a negative 26. Example 3, multiply rectangular matrices. Before we were just doing squares. These are now rectangular. We want to determine if the product exists. So if we're doing P times Q, so this one is a 2 by 3, and this is a 3 by 2. Middle numbers are 3, so I can multiply that, and my answers would be a 2 by 2. A number here, 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 and here. So I'm going to take row 1 times column 1. So I have negative 2 times 6 plus 3 times negative 4 plus 0 times 9. That's negative 12 plus negative 12 plus 0 gives us negative 24. This is row 1, column 2. So we have negative 2 times 2 plus 3 times 8 plus 0 times 10. That's negative 4 plus 24 plus 0 gives us 20. This one is row 2, column 1. So we have 1 times 6 plus 5 times negative 4 plus negative 1 times 9. So we got 6 minus 20 minus 9 gives us a negative 23. Then our last one This one is row 2, column 2. So 1 times 2 plus 5 times 8 plus negative 1 times 10. That makes it 2 plus 40 minus 10 gives us 32. Next one, determine whether the product exists for P matrix and Q matrix, and we're doing Q times P. So this is Q is a 3 by 2, and P is a 2 by 3. So our answer is going to be in a 3 by 3. So 1, 2, 3. 1, 2, 3. 1, 2, and 3. So this first one, row 1, column 1. So we have 6 times negative 2 plus 2 times 1. That's negative 12 plus 2 gives us negative 10. Row 1, column 2. So now we have 6 times 3 plus 2 times 0, 5. So that's 18 plus 10 gives us 28. Next one is row 1, column 3. So we have 6 times 0 plus 2 times negative 1. So this will give us negative 2. Next, we're in row 2, column 1. So this is negative 4. Negative 4 times negative 2 and plus 8 times 1. So that gives me 8 plus 8 is 16. Next, we have row 2, column 2. So negative 4 times 3 plus 8 times 5. So that's negative 12 plus 40 gives us 28. Next, row 2, column 3. So negative 4 times 0 plus 8 times negative 1. So that's going to give us negative 8. And again here we have row 3. We have 9 times negative 2 plus 10 times 1. Negative 18 plus 10 gives us negative 8. Next, we have row 3, column 2. So this is 9 times 3 plus 10 times 5. 27 plus 50 gives us 77. And the last one here we have 9 times 0 plus 10 times negative 1. That will give us a negative 10. So that would be our answer here. Next, RS. So let's do R. This is a 3 by 2, and this is a 2 by 3. Now for this one, I'm going to show you how to do it on your calculator. So we're going to do this on here. So we turn our calculator on, hit second, x to the negative first, which is our matrix. We need to go to edit. So our first one is going to be matrix R. So that's a 3 by 2. And we're going to type those numbers in. So 17, 9, 8, 5, 14, 18. Go to second matrix again, edit, but we now to go to matrix B. Hit enter, that's a 2 by 3. Type these numbers in, so 6, 1, negative 4, negative 7, 9, negative 3, There you go. Second mode, so get out of it. Now we go back in. Oh, second matrix. Now we're going to choose A, choose 1 times. Second matrix, we're going to choose number 2 or B. And when we multiply those, it gives us our solution here, which our answer should be a 3 by 3 because we had a 3 by 2 times a 2 by 3. So our answer is 39, 98, negative 95, 13, 53, negative 47, negative 42, 176, and negative 110. Next, determine whether you can multiply these. This one is a 1 by 3, and this is a 3 by 1. So a u times v, I can do that one, but a v times u, so 3 by 1. So if I have a 3 by 1 and a 1 by 3, I can do that. So this one's a 3 by 1 times a 1 by 3. So I would have a 3 by 3 here. For UV, this is a 1 by 3, and V is 3 by 2. So no, I can't do that one. This is a 3 by 2. So no, I can't. Well, this one I can. This one's going to be a 1 by 2. This one I cannot do that because this is a 3 by 2 by 2 by 1. So I can't do the VU. So for this one, I can do UV. So if I go back to my calculator, go to second matrix, go to edit. We're going to edit this first one. Our U is a 1 by 3. So edit. This is a 1 by 3. So I'll type those numbers in, 5, negative 3, and negative 4. And then matrix, edit the second one. This one is a 3 by 2. Type those numbers in, so 1, negative 6, negative 7, 5, 2, 0. Then get out of here, do second matrix, number 1 times second matrix, number 2. And we should have an answer that's a 1 by 2, so one row of 2. So we have, our answer would be 18 and negative 45. This bottom one, there is no solution for that one. Moving on. During the lunchtime hours, Sunnyside Cafe offers 3 specials as shown. 4 large group tables. Order the lunch special shown in the table. Use matrices to determine the total bill for the group tables. So this one is a 3 by 1, and this is a 4 by 3. So we have a 4 by 3 times a 3 by 1. So our answer is going to be a 4 by 1. So here, we can do the product here. So our answer is a 4 by 1. So let's put that down. Okay, so let's make these different color, red, green, and then this is blue. So let's do the black first. So row 1, column 1. So this would be 2 times 9 plus 6 times 11 plus 5 times 12. we have 18. Actually, quicker, let's just do it on our calculator since I've already practiced doing that pencil paper method. So second matrix, edit these. So we have a 4 by 3. And we got 2, 6, 5, 4, 8, 3, 6, 5, 1, 0, 3, 3, and then 8. Second matrix, edit, go down to the second one. That's a 3 by 1. And this is 9, 11, 12. Get out of here. Second matrix, we have 1 times second matrix, number 2, enter, and here's our answer. We would have 144, 160, 121, and 129. And to interpret what that means, we would say the total bill for table A would be $144, table B is $160, table C is $121, and table D is $129. Next, 3 teams competed in the final round of the chess club's championships. For each win, a team was awarded 3 points, and for each draw, a team received 1 point. Use the matrices to determine which team won the tournament. So again, we have our matrices down here. Put them in our calculator. So second matrix, edit. First one's a 3 by 2. So we'll have 5, 4, 6, 3, 4, 5. Next one, edit this one, and this is a 2 by 1. So we have 3, 3, and then 1. Second matrix, we have 1. Actually, I gotta clear this. Gotta get out of there. So then second matrix, got 1 times second matrix for 2. Our answer would be 19, 21, 17. So that means red team would have won the tournament. And our last one here, the National Hockey League awards 2 teams 2 points for a regulation win, 1 point for a loss in overtime, and 0 points for a regulation loss. The table shows the wins and losses for 3 teams in the NHL Atlantic Division for 2018-2019 season. Use matrices to find how many total points each team had for the season. So here is our matrix. We have a 3 by 3, and this is multiplied by a 3 by 1. Our answer is going to be a 3 by 1. Grab our calculators, type these in here. Second matrix, edit. This one's a 3 by 3. So we got 62, 4, 16, 36, 14, 32, 32, 10, and 40. Second matrix, edit, go down to the second one. This is a 3 by 1. So we have a 2, 1, and 0. Get out of this second matrix, be a 1 times second matrix, number 2, hit enter, and our final answer would be 128, 86, and 74. And the original question is find out how many total points each team had for the season. So the Lightning had 86. Panthers So if Lightning had 128, Panthers had 86, and the Red Wings had 74. So that is our lesson on multiplying matrices.